welcome to WinHEC Online, Windows 10 Fall Creators Update. My name is Luke Angelini. I'm a Program Manager with Windows and Devices Group at Microsoft. And today I'm going to talk about extension INFs and component INFs. The first thing I'd like to start off with is device installation basics. So for every device on a Windows device, there are a set of hardware IDs that describe it. These hardware IDs range from very specific to very generic. In my example here, I have a speaker device, and it has everything from a very generic PCI class code all the way up to a very specific hardware ID that describes this specific device. For drivers, on the other side, we have an INF, and every INF refers to a very particular hardware ID. So in my example here, I have three. I have INF A, INF B, and INF C. For these INFs, they each have a specific hardware ID on which they match. The first one is our best match. It references the second most specific hardware ID on our device. The second INF, INF B, would also work to run this device. So if INF A did not exist, INF B would be used, and it matches on that first compatible ID. In this example, INF C matches on a hardware ID that isn't present on this device, so it would not be installed. We use this ranking process to decide what the best INF is to run on a device. Extension INFs are just like normal INFs in that they match on hardware IDs. The difference is you're allowed to have more than one INF on that device. So every device must have one and only one base INF. And this is very similar to my original example, and that runs the fundamental usage of the device. The extension INF is then layered on top of that, extending its functionality and providing more value add. In my example here, the base INF is INF B, and it matches on a more generic hardware ID for my device. My extension INF is INF A, and it matches on a more specific hardware ID for my device. Extension INFs can be provided by different companies and serviced independently, or they can all be provided by the same company that produced the base. In writing your INF, it looks and feels exactly the same as your base INF, but instead of providing the fundamental functionality, it's providing customization and specialization. You should always think of an extension INF as enhancing the value of the device, building upon that functionality, but is not necessary for the primary functionality of the device. All extensions must be universal INFs. A device must have one base, but it can optionally have anywhere from 0 to as many as you'd like extension INFs associated with it. Typical scenarios would have a single base INF running the core functionality of the device, and one extension INF that provides customization, such as a friendly name, configuration, tweaking settings. Another scenario when an extension INF may be used is to define a software component to extend that device. When using a software component, you would use the add component directive and provide a component INF. This leads into our next section about component INFs. Whereas extension INFs are extending core functionality, a component INF is adding additional device nodes to provide additional functionality for the device. Fundamentally, component INF is just another base INF. In my example here, I have my original speaker device from my original samples, and it has its multiple hardware IDs. And its INF A, which is its core functionality, matches on one of those hardware IDs. In that INF A, we specify the add component call, which generates a new hardware device node as a child device of that parent speaker. In my example here, it has this vendev of 02. This new hardware identity is matched with a completely new INF as a separate install process. In my example, that's INF B here below. Component INFs are intended to create sections of functionality that you might distribute across multiple devices, or you would otherwise want to separate from the core functionality of the device. You can use as many components as necessary depending on how you want to update interdependent functionality of the device. To create a child device, a parent extension INF specifies that add component directive. And then you have that new node, and you can match on it with your component INF as necessary. If you're using the add software directive, which is a separate functionality added to allow for installing specific software for your device, that component INF must be a universal INF. It must specify the software component setup class, and you're allowed to use that add software directive one or more times. Since this is an add software functionality, it doesn't actually require a true function driver for that to work. Thank you very much for listening about extension INFs and component INFs. Please fill out the survey below and provide your feedback on the session. Thank you very much.